Welcome to the Explainer. You know, some software seems like it's built to last forever, right? While other projects, well, they just collapse under their own weight. What's the secret sauce? Well, a lot of the time, the difference comes down to 5 really powerful design principles. And today, we're talking about Solid.
All right, so here's our game plan for today. First, we're going to dig into why we even need something like Solid. What's this software rot all about? Then, we'll get into the philosophy behind it and, of course, break down the 5 principles one by one. After that, we'll zoom out and see why this stuff actually matters in the grand scheme of things. And finally, we'll wrap up with some real-world practical advice on how to use these ideas without going overboard.
Okay, so first things first. To really get why Solid is such a big deal, we have to talk about the problem it's trying to fix. And that problem has a pretty nasty name: software rot.
So why does good software go bad? I mean, it's a question pretty much every dev team asks themselves at some point, right? You start a project, it's clean, it's beautiful, everything makes sense, but then time happens. You add a feature here, a bug fix there, and slowly but surely, it just starts to decay. It gets harder to change, riskier to even touch. What is going on?
Well, that decay, that's what we call software rot. And the symptoms are probably all too familiar. First, there's rigidity. That's when you try to make one tiny, simple change, and suddenly you have to update a dozen other files. It's like pulling on a single thread, and the whole sweater starts to unravel. Then you've got fragility. That's when you make a change over here, and for some reason, something totally unrelated breaks over there. It turns development into a slow, expensive, and let's be honest, pretty demoralizing process. And you know, at the very heart of this rot is this idea of coupling. Just look at the left side here. That's tight coupling. It's a tangled web, a big ball of mud where every part of the code is intimately tied to every other part. You change one thing and the whole system starts to tremble. It's brittle. But on the right, that's our goal: loose coupling. Think of it more like Lego bricks. Each module is independent, self-contained. You can swap one out or change it, and the rest of the structure stays solid and stable. So, the big question is, how do we get there? How do we escape that tangled mess and build systems that are more like those Lego bricks? Well, it's not by accident. It takes a deliberate, disciplined design philosophy. It's a framework for thinking about how we build software that can actually stand the test of time.
And these ideas have been around for a little while. They were first really pulled together and written about by the one and only Robert C. Martin. You probably know him as Uncle Bob, way back in the year 2000. But it was a few years later, in 2004, that Michael Feathers gave us the awesome acronym SOLID. And that's what made these principles so catchy and easy to talk about.
And this is a really important point. Before Solid gave us this language, how did we talk about bad code? It was all kind of vague, right? Someone might say a piece of code just feels messy, or it's confusing. But what does that even mean? Solid changed the game by giving us a shared, technical vocabulary. Now you can point to a class and say, hey, this violates the single responsibility principle. And boom, everyone on the team knows exactly what you're talking about and what needs to be fixed. It's specific, it's actionable.
So when you boil it all down, the whole mission of Solid is to manage complexity. It does this by aiming for 2 things. First, high cohesion. That's just a fancy way of saying that things that belong together should stay together in the code. And second, loose coupling, which we just talked about, making sure that unrelated things stay separate. If you can nail those 2, you end up with a code base that's way more organized, way more resilient, and much easier to change down the road.
Okay, let's get into the nitty-gritty. What do these 5 letters in Solid actually mean? Let's break them down.
So here they are, all 5 principles laid out. You've got S for single responsibility, one class, one job. O for open-closed, open to being extended, but closed to being modified. L for Liskov Substitution, making sure child classes can stand in for their parents. I for interface segregation, don't force classes to implement things they don't use. And finally, D for Dependency Inversion, depend on abstractions, not on concrete things. Each one of these is a weapon against that software rot we talked about. Now, to make this really concrete, let's zoom in on that last one, dependency inversion, because it's a fantastic example of the Solid mindset.
Okay, I know dependency inversion can sound a little abstract or academic, but trust me, once it clicks, it's a total game changer.
And there's a really simple analogy that makes it all make sense.
Just think about a TV remote. The remote doesn't care if you put a Duracell battery in it, or an Energizer, or some generic brand. It doesn't depend on the specific brand of battery. What does it depend on? It depends on the standard of a AA battery. The shape, the size, the voltage. That standard is the abstraction. Both the remote and the battery company agree to follow that standard, and because of that, they're completely decoupled. You can swap batteries all day long. That is the heart of dependency inversion.
All right, so we know what the principles are, but why bother? I mean, this sounds like extra work, right? So let's talk about the so what. What's the real strategic value here? What's the long-term payoff? And the benefits are, well, they're huge. When you build with Solid in mind, you get code that is just so much easier to maintain. That means your technical debt goes down. Your system becomes more scalable and flexible, ready for new features. It's also way easier to test, which means better quality overall. And when you add all that up, your developers are more productive, and the entire business can move faster and adapt to new challenges. It's a massive win-win.
And this chart, this really brings it home. It shows you the economic reality over time. Look at that bar for non-solid code. The cost to make a change just keeps going up and up and up. It gets exponentially more expensive. But that other bar for solid code? The cost stays low, stable, and predictable. You're basically future-proofing your investment, protecting your ability to evolve without going bankrupt.
So here's the bottom line, and it's so important. Thinking about Solid isn't some extra cost you tack on to development. It's not just for the engineers. It is a strategic business investment. You are investing in your company's power to innovate, to adapt, and to respond to the market without being trapped by the very technology you built.
Okay, but let's be real. Knowing the theory is one thing. Actually using this stuff day to day, that requires a healthy dose of pragmatism. It's not about just blindly following a set of rules. And this is a trap a lot of people fall into. You have to avoid being dogmatic about Solid. If you just treat it like a rigid checklist, you can actually make your code worse. You end up with something called hyper-decomposition, where you have 100 tiny little classes and interfaces, and nobody can figure out what the heck is going on anymore. The goal is to be pragmatic. Use these principles to solve real problems, not to create new theoretical ones. This, of course, brings up that classic debate between something like Solid and another great principle, KISS, which stands for Keep It Simple Stupid. And there's a tension there for sure. A solid approach might seem a little more complex up front. But you have to remember that today's simple solution can easily become tomorrow's nightmare of complexity. The real art, the real skill of a great engineer is finding that perfect balance, building something that's simple enough for today, but robust enough for the inevitable changes of tomorrow. At the end of the day, Solid isn't just a bunch of rules. It's a philosophy. It's a mindset that guides you to build software that can evolve. It helps you architect systems that not only work perfectly today, but are also ready to face the unknown challenges that are definitely coming tomorrow. So the next time you're sitting down to code, just ask yourself this one question. Am I just building this to work right now, or am I building it solid for the future? Thanks for joining us on The Explainer.